What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button, and make sure you watch all the way through. There's a lot of good stuff coming. Let's get
From the
to
tower
it.
to the electrovalve. I don't really like to go off topic into historical excursions, but the history of the injector is quite curious. Some may remember that originally Rudolf Diesel wanted to burn coal dust rather than diesel. It turned out badly. This dust does not have a very high heat output. However, the idea to atomize powder as a fuel was not only visited by Diesel. Alexander Ivanovich Bukovsky made the first nozzle for powder as early as 1864. But it was no more successful than Diesel's. Something new had to be invented, a nozzle for liquid fuel. And here again, our compatriot Vladimir Grigorievich Zhukov distinguished himself. Yes, the same Zhukov whose project was used to build the famous TV tower on Shabalovka. But it was much later, and in 1880, at that time still a student, Zhukov invented a nozzle for liquid fuel. Alfred Nobel's brother Ludwig liked this invention very much. He liked it so much that he bought the patent and began to put Zhukov's nozzles on sea vessels. And for the further development of nozzles we should say thanks to Robert Bosch. He invented several types of nozzles for liquid fuel at once, and the main thing is that he made friends with a high-pressure pump. Of course, injectors appeared in diesel engines earlier than in gasoline engines with carburetors. However, already in the 1970s, with the appearance of so-called injector systems, injectors had to be put on gasoline engines. Now, probably not everyone will remember the early versions of the injector with mono-injection, one injector on the intake manifold instead of the carburetor. Nowadays injectors are put on each cylinder separately, and there is both simple distributed injection into the intake manifold and direct injection into the cylinders. There are also motors with combined injection, where injectors are in each cylinder and one in the intake manifold. Problems of direct injection injectors are a bit specific, so today we will talk about the most common problems of injectors of distributed injection motors. During its development, injectors have been divided into several types according to the principle of their operation: mechanical, piezoelectric, electrohydraulic and electromagnetic. The first three are usually used on diesel engines. At the same time, piezoelectric can meet and gasoline, well, in gasoline engines. With distributed injection work relatively simple and reliable electromagnetic injectors. But are they simple? Fast, accurate, economical? So, how does an electromagnetic injector work? Theoretically, it's not very complicated. The injectors stand on the fuel ramp, where the gasoline pump supplies gasoline under decent pressure. The task of the injector is to open, inject fuel and close on the command of the ECU. For this purpose, an electrical impulse is applied to the solenoid winding. Under its influence, a magnetic field appears, which tightens the armature. The anchor rod is connected to the shutoff needle. As soon as the armature goes inside the coil, the needle opens the atomizer nozzles and the injector injects fuel. The clicks that the injectors make, not even clicks, but a clanking sound that can be heard at idle crankshaft speed, are the result of the solenoid cycling and the armature running back and forth inside the injector. It seems simple, but the whole nozzle is one big compromise. On the one hand, the needle must be very strong and reliably cover the nozzles of the atomizer at the moment when there is no voltage on the winding. On the other hand, the needle must not be too heavy. The more massive it is, the more inertia it has, and therefore the lower its speed. Meanwhile, the injector performance is determined by the total valve opening time, because during one injection cycle a modern injector has time to open and close several times. So making the perfect injector is not as easy as it seems. A lot depends on the accuracy of the injector, that's obvious. What is not so obvious is that even the environmentalists have their hands in this device. They force modern engines to run on a lean mixture, and this requires the most accurate operation of the nozzle. Unfortunately, or fortunately, the performance of an injector in a given period of time depends solely on the time for which the nozzles of the atomizer are open. The nozzle diameter or fuel ramp pressure cannot be changed by the injector, so its only tool is the actuation time. At the same time, the injector must be able to survive millions of cycles without replacement, which is also quite difficult. Therefore, I will repeat once again, despite its simplicity, the injector is a very technological device. And sometimes it stops working properly. Not pouring an injector can have three typical malfunctions. It may not flow fuel when it should. It may flow when it should. It may flow when it should, but not properly. Now for more details on all three situations. What does it mean, not passing fuel when it is necessary? Firstly, the signal for opening may simply be lost. There may be an open or short circuit in the injector wiring. Secondly, there are always impurities in gasoline that form deposits on the injector. The deposits can clog the atomizer, and then the injector will not be able to pass gasoline either. However, impurities more often cause the injector to pass fuel, but it does it incorrectly. The second situation is loss of tightness. In this case, the shut-off needle is not able to close the atomizer nozzles, so the nozzle starts to leak. This malfunction is much more common than the first. And it is explained more easily. There is a whole set of reasons, ranging from the same deposits to the wear of the needle itself. It is good that it is not too difficult to detect leakage of the injector. Besides, it is possible to meet leakage of the nozzle body. In this case, the internal seals dry up, and gasoline goes into the winding, and from there it flows outwards well. And the third potential surprise is an incorrect atomization of gasoline. Theoretically it should be finely dispersed, but in some cases the atomization torch is broken to such a state that the gasoline starts to leak, and from one side. Or it may not leak, but on the contrary, it may come in less quantity. And also the shape of atomization torch can be simply broken, which is also bad. It will not be possible to create a homogeneous fuel air mixture, and its combustion will be incorrect. So how to realize that something is wrong with the injector? Look and listen. English. A leaking injector can be indirectly traced by an uncertain start and a spark plug that quickly becomes sooty. If the spark plug in any of the cylinders quickly grows black soot, their ignition skips, which disappear after cleaning or replacing the spark plug and reappear in this cylinder. Most likely, the injector has lost its tightness. Another way to identify problems with the injector is to analyze the fuel mixture. A rich mixture can speak of an overfilled injector. But, firstly, the cause of rich mixture may be different, and secondly, without experience with a scanner, it is difficult to understand the nuances of fuel correction, so you will not be able to identify the injector right away. Unfortunately, it is impossible to do anything more interesting without removing the injectors. If there is a very big craving for practically useless actions, you can measure the resistance of the solenoid winding, but hardly any car enthusiast knows what it should be in nominal value. Here it will be possible to find only a break or short circuit of the winding, but this happens very rarely with the nozzle. Therefore, it is better to remove the entire ramp and see how the injectors look from the side. At the same time, the ramp should not be disconnected from the fuel line. We need to see leakage or atomization shape disturbance. The easiest thing to do would be to see the current injector. Usually it is enough to turn on the ignition and wait for the gasoline pump to pressurize the ramp. If after that some injector has started to leak, it will have to be replaced. Then you can put the ramp in some container and spin the crankshaft with the starter. At the moment of starting the engine, the injectors are already working, so how they atomize fuel will be clearly visible. The main thing is not to atomize it with a cigarette in your mouth. If on one of the injectors the shape of the torch is very different from the other injectors, it is better to replace it or at least flush it. Although not everything is not so clear about flushing injectors, and sometimes flushing can be the last event in the life of an injector. I should note that sometimes an injector may leak in specific conditions, for example, only in cold weather, or on the contrary, after warming up. In this case the diagnostics will be more complicated. Just in case, I will repeat once again, it is possible to check injectors completely, including their performance, only on the stand. And if the injectors have to be removed, pay attention to the condition of the sealing rings. It is better not to install them again because of possible air inflow. In conclusion, understanding why a gasoline engine injector may stop working is crucial for maintaining optimal engine performance. Factors such as clogging, electrical issues, and wear can lead to injector failure, resulting in poor fuel atomization and reduced efficiency. Regular maintenance and timely diagnostics can help prevent these issues, ensuring your engine runs smoothly and efficiently. By addressing these potential problems proactively, you can extend the life of your injector and enhance your vehicle's overall performance. Thank you for watching, and stay tuned for more insights on automotive care.